in this section, we are gonna deduce a formula for differentiation. In the end, we are gonna get differentiation formula like this. If you have a polynomial called y equal to ax raised to the power of n, then the differentiation dy dx is equal to n. You know, the n here, the power, multiply that with a, and then x raised to the power of n minus 1. So this is what we are going to prove. And the way we are going to do this here is that by executing a differentiation for 5 polynomials that I put in these two tables and write the results in the column of dy dx by using the limit method that we have learned in the previous section. Because we have 5 polynomials, so this section is going to be a little bit repetitive. It's going to be a bit tedious to do, I admit, but this is going to be a good learning experience. So if you're fine by using this formula and do not want to go through the whole deduction thing, you know, you don't want to go and prove that, that's fine. You know, you can go to the next section. But I can assure you, by going through this section, you're going to learn a lot about how we prove that this formula is really true. Okay? But if you know, I can basically guarantee you, halfway through of this video, halfway through of this section, you will start recognizing, you already be able to go and prove the formula that I have written over here. You can go through halfway through 50% of this video and jump right out, go to the next section. That is fine too. Otherwise, you just stay with me and do all these 5 polynomials together. Okay, ready? Let's go. First one, y is equal to x. I give this as the first equation. And then, as we have learned in the previous session, if y is increased by delta y, there's a change of delta. No, what I'm saying is that if x is being changed by delta x, there's a change in the x plus delta x, then we believe that there is a change as well in y, whatever that change is. Then we have y plus delta y. We do not know yet the value of delta x, delta y, but in the end, we are going to use limit method. We push delta x close to 0, become insignificantly small. Okay, let's go. So this is our equation 2. So equation 2 minus equation 1, then we have delta y equal to delta x, and everything divide that with delta x because we want to get dy dx in the end. Remember? Okay, then delta y delta x is equal to delta x divided by delta x. What do you get? 1. Exactly. So we use limit method, it doesn't really matter. Delta x approaching 0. Delta y delta x is equal to 1 no matter what. So dy dx is equal to 1. So let's update the table. 1. You can also notice a column called pattern here. What does it do? Well, let's wait. Let's just do a number of it, then you'll start to see a pattern there. I promise. Okay, let's continue with the second polynomial. Just get rid of this. Have to create space. Y equal to x squared. This must look familiar to you by now. So y plus delta y is equal to x plus delta x squared. If you do this, often enough, then it's gonna be really easy. This limit method of proving equation of dy dx is really easy. You get a hang of it. So y plus delta y is equal to x squared. plus 2x delta x plus delta x squared. This is our equation 2. So equation 2 minus equation 1. Take out the y from the left hand side. We've got delta y. Y is gone, right? So x squared is gone as well, because x squared minus x squared is nil, 0. So 2x delta x plus delta x squared. And this whole thing, divide that by delta x, because we want to have an expression of delta y over delta x. Then we have delta y delta x equal to 2x delta x divided by delta x. We have left with 2x plus delta x squared divided by delta x. We have delta x. Okay, now limit delta x close to 0. So delta y delta x is equal to 2x is not really impacted because x can be of any value. So 2x, but delta x is now close to 0. Let's just forget about it. This is what we get, 2x. So dy dx is 2x. Let's update the table. Next one. You've got a hang of it. Can you see the pattern already? Maybe or maybe not. Y equal to x cubed. Our first equation, y plus delta y equal to x plus delta x cubed. And how do you expand this? You can use Pascal triangle, or you can also do this manually. X plus delta x times x plus delta x plus x plus delta x. Yeah, go ahead and multiply all those three functions there. It's not really it's not something that I want to spend my time here, so I'm gonna use Pascal triangle that I'm already familiar with. That is y plus delta y equal to x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Later on, when delta x, we use limit that delta x approaching 0, then you know that everything from here onward will be eliminated. So let's do that. Oh yeah, by the way, this is equation 2. So 2 minus 1. This whole thing divided by delta x. We can do this with our eyes closed already by now. So what happened with the rest? Everything is gone because the delta x is a bit too small. Multiply with 3x. Let's just throw it out into a dustbin, as well as delta x squared. Everything is gone. Update table. By now the pattern should be, or maybe a little obvious. Let's just go through the fourth polynomials. Then it will become evident of the pattern. Again, we use Pascal triangle to expand that expression. going to be long, but you know what, later on I'm going to ignore this because we know it's going to be eliminated anyway. Okay, this is equation 2. It's really tedious, I must admit. There's something that I made a mistake here. And the rest is not important because it will be gone. It will be gone, all right? And this whole thing divided by delta x okay. Okay, there you go. Something's not completed. There you go. Update the table. I'm sure you can see the pattern. I'm sure by now you realize that the formula is true. But who knows? Let's go and do the remaining 6. Expand that. But I'm not going to expand everything. I'm going to just pick up the most important part. And the remaining I do not care because they are going to be gone anyway when the delta x is approaching 0. There you go. Okay, we are done with the first 5 polynomials. We're going to do the second table with slightly different polynomials because we have 5 as the coefficient of x. Let's do that. And you're going to see the striking similarities, the striking pattern as we go through it.